There we go. Now I'm sharing. Okay, so triangles and their side lengths. So we can classify triangles by their sides and their angles. So these are the different ways we can classify them. If we are going to classify triangles based on their angles, what we're going to do is identify if there's 3 acute angles, then we have what we know is an acute triangle. So acute triangles have 3 acute angles. If it is a right triangle, it will have 1 right angle. And if it is an obtuse triangle, it will have 1 obtuse angle. So these are the different ways that we can go ahead and classify triangles based on their angles. 3 acute angles, acute triangle. 1 right angle, a right triangle. 1 obtuse angle, an obtuse triangle. We can also do this with side lengths. If all 3 sides are congruent, it is an equilateral triangle. So 3 sides congruent. If at least 2 sides are congruent, we have an isosceles triangle. And if absolutely no sides are congruent, we have a scalene triangle. Again, if we have 3 sides congruent, it's going to be equilateral. If at least 2 sides are congruent, it's going to be an isosceles. And if absolutely no sides are congruent, it's going to be a scalene triangle. So these are the different ways that we can classify triangles based on their angles and their side lengths. Is there any questions about these? No? Okay, so let's look further at obtuse triangles. If we do in fact have an obtuse triangle, for example, here we take Q as obtuse, well, we get a special relationship with that. If we have 1 obtuse angle, obtuse meaning greater than 90 degrees, then based on that and based on the relationships that we know about all the interior angles of a triangle, we'd be able to determine that our remaining 2 angles will be acute angles. They'll be less than 90 degrees. How do we know this? We'll say that my obtuse angle here is 91 degrees. Okay, 91 degrees is in fact greater than 90, so it is obtuse. And I know that all my angles add together have to equal to 180. So P plus R plus Q has to equal to 180. Let's figure out how much of my angles I have to distribute between P and R. P plus R have to equal to 89 degrees. What that tells me is that I have 89 degrees to distribute into angle R and angle P. Well, that means that neither angle R nor angle P will be greater than 90 degrees or 90 degrees. Because if P were 90 degrees, then we'd already surpass our limit of being 89 degrees. If R were 90 degrees, we would surpass our limit of being able to get the remaining angles into the 89 degrees. And so basically what this is saying is that if we have an obtuse triangle, that obtuse triangle will have 1 obtuse angle and 2 acute angles. Because none of those angles can be right or obtuse because all the inside angles have to equal to 180 degrees. Any questions about this? Okay. Now we're going to get into one theorem that we're going to look at today. This is the triangle inequality theorem. This theorem basically just says the sum of the lengths of any 2 sides is greater than the length of the third side. So basically the sum of any 2 sides is greater than the length of the third side. So if I was trying to find the length of B, B has to be less than the sum of A and C. if I was trying to find A would have to be less than the sum of B and C. If I were trying to find C would have to be less than the sum of A and B. That's what this theorem is telling me. So, what does that look like? We'll say that I know that this is 8 and this is 10, and I'm looking for this missing side. What does C have to be less than? Well, C has to be less than the sum of A and B. 8 plus 10. C has to be less than that. So 18. C has to be less than 18. That's basically what this theorem is telling me. I can do another example. If this is 1 and this is 3, what is this missing angle? Well, what does B have to be less than? B has to be less than the sum of my other two angles, or my other two lengths. So 4, B. So B has to be less than 4. So that's what that theorem is telling me. My missing side length or my third side length has to be less than the sum of either of my other two sides. So, keyword here is sum. It has to be less than the sum. So those two sides added together. Given that, what we can also identify is what these missing sides have to be greater than. Well, if they have to be less than the sum, then they'll be greater than the difference. If they're less than the sum, they'll be greater than the difference. So what does that look like? So this allows me to create bounds for which my missing side has to exist again upon. So let's say this is 7, this is 3. What is this? Well, C has to be less than the sum of my two sides, but it has to be greater than the difference between my two sides. So 4, 10. This tells me that C has to be greater than 4, but less than 10. So C is going to be less than the sum and greater than the difference. Less than the sum and greater than the difference. Less than the sum, greater than the difference. So we'll look at another example. This is 5, this is 3. I'm looking for this one. A has to be less than the sum and greater than the difference. So A has to be greater than 2 and less than 8. Okay, any questions about this theorem? We're going to see one more example right here in just a second. Less than the sum, greater than the difference. Okay. Given that, here we have an example. This is what is the possible lengths of C if A is equal to 10 and B is equal to 4. 10, 4, what is my missing length? What is the possible length of C? Well, C has to be less than the sum, greater than the difference. Six, 14. This tells me C has to be greater than 6 and less than 14. Okay, and that's the triangle inequality theorem. Any questions about the triangle inequality theorem? Okay. Now we're going to look at deep-rooted and isosceles triangle. An isosceles triangle is a triangle with at least 2 congruent sides. The key word here is at least, and we'll get into why that is. And isosceles triangles can be acute, right, or obtuse. So here we have an isosceles triangle. Two sides are congruent. And if it's acute, then all three angles are acute. Here we have a right triangle. This right triangle is isosceles because it has two congruent sides. And it is a right triangle because it has one right angle. Here we have an obtuse isosceles. Again, we have two congruent sides, at least two. And we have one obtuse angle, making it obtuse. So isosceles triangles can be either acute, right, or obtuse. Any questions about this? No? Okay. So we're going to go ahead and look at the angle restrictions based on side lengths. So here we have this diagram. With this diagram, we want to consider what each of types of these triangles are. So I'm going to start with SQT. What I notice is SQT has two congruent sides. That means it's isosceles. It has at least two congruent sides. And what I'll notice, it has three acute angles. So it is also acute. Well, that means I can call it acute isosceles. Let's look at PRQ. What do I notice? It has at least two congruent sides, so it's isosceles. And it has a right angle, so it is a right triangle. And so therefore, it is a right isosceles. What about this one? Well, I'll notice it has at least two congruent sides, so it's isosceles. And it has one obtuse angle, so we can call it obtuse isosceles. Okay, let us remember that we can name triangles based on their side lengths and their angle measures. So, angles, sides. If it is a acute angle, it will have three acute. If it is an acute triangle, it will have three acute angles. If it is an obtuse triangle, it will have one obtuse angle, and we solved that it will also have two acute. If it is a right triangle, then it will have one right angle. If all the sides are equal to each other, all three sides are congruent, it will be equilateral. If at least two are congruent, at least two, can be more than two, but at least two, it is isosceles. And if absolutely no sides are congruent, then it is scalene. So we're using these definitions and these categories to be able to classify our different triangles. Now let's look deeper at equilateral triangles. An equilateral triangle, we looked, has three congruent sides. All three sides are congruent. Well, what you'll realize is that if a triangle has three congruent sides, then it also has at least two congruent sides. Again, to have three congruent sides, you can have at least two. To have at least two, you can have more than two. You can have less than two, but you can have two or greater. And so because an equilateral triangle has at least two congruent sides, it can also be called an isosceles triangle. And just a heads up that all equilateral triangles must be acute. If it's equilateral, then it's equiangular, meaning it's acute. All three sides are the same. If I know all three sides are equal to 180, 180 divided by 3, each side is 60 degrees, which is an acute angle. Well, that being said, if I know that my equilateral triangle can be an isosceles triangle, but I also know that it has all acute angles, then I know that my equilateral triangle can also be an acute isosceles triangle. Why? Because all of the angles must be acute in an equilateral triangle, and I have at least 2 congruent sides. Okay? So what we're able to do today, we're able to classify triangles based on their angle measures. We're able to classify triangles based on their side lengths. And we're able to apply the triangle inequality theorem, which tells us the sum of the length of any 2 sides is greater than the length of the third. Again, my side is greater than the difference and less than the sum. Greater than the difference, less than the sum. Greater than the difference and less than the sum. Okay, any questions? Okay, if there's no other questions, I will see you guys on Monday. Have a great weekend. Bye, guys.